The overall goal of this procedure is to use electrolyte gating to control the carrier number and achieve electric field-induced quantum phase transitions in tungsten disulfide transistors.
This technique provides a powerful strategy for achieving quantum phase transitions, including electric field-induced superconductivity.
The main advantage of this technique is that strong electric field can be generated even under low bias voltage, inducing large carrier density by electrostatic or electrochemical doping.
To begin preparing the nanotube dispersion, combine about 0.8 milligrams of tungsten disulfide nanotubes with 8 milliliters of isopropyl alcohol. Sonicate the mixture for 20 minutes to disperse the nanotube powder in the isopropyl alcohol. To avoid heating the suspension, rest it for 1 minute after every 5 minutes of sonication. Next, turn on a spin coater and its attached vacuum pump. Place a clean silicon dioxide substrate at the center of the vacuum chuck and fix it in place. Apply the 0.1 mg per milliliter tungsten disulfide nanotube suspension to the substrate in drops until the substrate surface is completely covered. Spin coat the substrate at 4000 rpm for 50 seconds. To begin preparing the tungsten disulfide flakes, place a small bulk sample of tungsten disulfide on the adhesive side of silicone-free adhesive tape. Carefully fold and unfold the tape to mechanically exfoliate a thin layer of tungsten disulfide from the bulk. Continue folding and unfolding the tape